A solid sphere rolls without slipping on a rough surface and the center of the mass has constant speed v0. Solid sphere. If the mass of the sphere is m and radius capital R, find the angular momentum of the sphere about the point of contact. Matter. You can do it orally also if you want, if you are smart enough. Draw one diagram and then you can analyze, or you can imagine, you can do it without diagrams.
Yes.
Good. Good, great.
Yes, sir.
Great. So you will calculate the angular momentum about the center.
Yes, sir.
Right? And then using parallax theorem, you will shift it to the point.
Yes.
Okay?
Yes.
So the angular momentum of the center is 2 by 5 mr square.
Yes, sir. About
Okay? Plus mr square. We'll give you that. Okay? And the omega. Omega is equal to V0 into R. Okay? Hello, V is V0 is equal to omega into R. So omega you can write it as V0 by R whole square.
Yes.
Right? I hope all of you understood what I told.
Yes, sir. Yes.
Okay? So that's it. So you have the sphere. So it's all about this point of contact. Okay? So about this point, it is the moment of inertia for the center is 2 by 5 m r square. Okay? And the angular momentum over this point you calculated.
Yes, sir.
Right? What is the answer you got?
7 by 3.
Arey, wow.
Yes, sir.
You Dada, see, I am finding here Deeman Patapat answering, Arun Patapat answering, and I think Srijan and Omar answering. I don't know, others are not answering. I am not hearing you answering. I think you can also answer. Okay? See, this chapter is looking the easiest chapter. Okay? Amongst all the chapters. They are finding it. Okay. So, you calculate here. So, what is the angular moment? So, what is the, so here is IC, and about this point, P if you take here, then it will be IC plus, okay, plus M R.
Yes, sir.
Okay, so to this if you add, you will get 7 mr square by 7 by 5 mr about the point P. Using parallax theorem. And omega is same. Okay, so they are given V0. Okay, so V0 is equal to omega, or omega is equal to V0 by R. It is known. So angular momentum at this point, if you angular momentum at this point is IP into omega. Omega will not change. Correct? Hello?
Yes, sir.
7 mr square by 5 into omega. Omega is V0 by R. Right? So you will get here 7 mr V0 by 5. Is the answer. Okay, friends?
Yes, sir.
Yes.
See, these are all NEET problems. All these are NEET problems. Okay? One level up, you have mains, and 2 levels up, you will have advanced. Okay, basically. See, one thing is, NEET students should not say, oh, I am teaching high level and all. No. Because as I told you, out of 45 questions, 30 questions will be direct like this. But 15 questions will be at a slightly higher level. So your top ranking in NEET will depend upon who can solve those 15 questions. That is why I am teaching you at a slightly higher level. So if you see, if you are supposing you have to learn at this level, but if you learn at this level, if you get knowledge at this level, then this knowledge, the knowledge at this level becomes easy. I hope you understood what I said. You slightly learn more, then whatever is below that it will start appearing simpler, and that is important for this competitive exam because you have to answer them within split seconds.
Yes.
Alright, and this is not difficult for a mind who is ready to learn, enjoy learning. All this is very, very simple. Trust me. And such a beautiful chapter, they say, oh, RBD, leave it 1 mark, no weightage and all. So we got the answer in one shot. Okay. Right, friends? Methods of impulse and momentum. Okay, so we have done this earlier for this one, the same thing. So same thing is defined, but I am using different symbols here in books. In different books, they use different symbols. So methods of impulse and momentum describe what happens over an interval of time. When the motion of body involves rotation, we have to consider angular impulse as well as angular momentum. In this section, we discuss concept of angular impulse and angular impulse principle and conservation of angular momentum. So this term, see, angular impulse momentum principle. What is that? So you can see here. So here, because you see this term. So this is JO 1 to 2. So the torque to about mass is going to angular impulse during the time interval T1 to T2 is given by this. So tau naught into T2 minus T1. So there we write F into T2 minus T1. So here it is tau naught into T2 minus T1. Okay, and finally, if it is over a continuous time interval, then the integration T1 to T2. It should not be difficult for all of you, right?
Yes.
Now angular impulse momentum principle. So rearranging. Okay, so we get summation. Okay, tau bar dt is equal to L over this. This is called angular impulse momentum principle. We have got the similar thing, impulse momentum principle in linear.
Yes.
Okay, angular momentum is this. See, this term, suppose in examination they ask you, you have to write this and write a few sentences about it. Then you should write a sentence or two about what do you mean by the left hand side and right hand side and all. And obviously this is another thing which you have to write, because initial momentum vector, right, plus the summation of the many impulses that act. Many impulses that act. So you remember this. This is equal to LO bar, right? So you remember this, friends, one diagram in the case of linear momentum we had written. What is it? So you had PI bar. Remember? Okay. Then you had, what is this? Okay, J1 bar. Impulse.
Yes.
Acting on the body.
Yes.
Then you had this. What is this vector? This is PI bar is the initial momentum vector, linear momentum. This was the impulse that was given to that body.
PF, sir.
And yes, wonderful, wonderful. So PF.
Yes, sir. PF.
Fatafat. Understood? No? So this is what is it. Now instead of this, we have here, what is it? Li bar.
Yes, sir.
Okay.
Yes.
And this J bar will be same. Only thing is here you see this J bar here was what? Integration of F bar dot dt. Okay. And it was from T1 to T2.
Yes, yes, sir.
Right?
Yes.
Here this is only what? Tau bar. But tau bar dot dt. Okay, T1 to T2. Why? Because you have to always reference it with respect to a point. So as a force is concerned, there is no reference. I mean, this force is acting on a body or a particle, you simply write Fi. So here it is this. So that makes a difference. And this gives you what? The LF. There.
Yes, sir.
Right? Vector rays of Murthy. Okay, friends? Like linear impulse principle, this angular momentum provides us the solution to problem concerned with change of angular velocity in time interval or change of angular velocity during a very short interval in this.
Yes, sir.
See, there is a difference between short time interval and infinitesimally small time interval. Short time interval, long time interval, infinitesimally small.
Yes, sir.
There is a difference between the two. Method of impulse. So I hope you remember this. So this is this is the initial diagram. So you can see angular momentum and also linear momentum. Plus you are giving all these wonderful impulses, and that results in the final change. IC omega naught m Vc2.
Yes, sir.
Okay. So we had a similar picture last time. Okay. Right. So the diagram itself explains a lot of things. Clear, friends?
Yes, sir.
Yes.
Now, There is something here. Can you all read this, friends? Conservation of angular momentum in collisions. When a point mass, see I have underlined it, collides with a rigid body, the two exert an equal and opposite impulses on one another, as per Newton's law. The torque of these impulses is zero about any inertial reference point. The torque is also zero about the center of mass, and even if the center of mass frame is non-inertial. Can anybody explain this? During impulse, वगैरह वगैरह,
Sir, because center of mass at that point where the center of mass will indicate, that point cannot rotate. It cannot rotate, so it can have a translated motion. So
you are answering nicely. You have understood. I am so happy. But some conceptual terms we should use.
okay.
You are right. I understood what you said. Good. Anybody? Yes, what you said is correct. But you have to use the right concept. Hello, my dear friends. See, when point mass collides with a rigid body, the two exert equal and opposite impulses on one another by Newton's third law.
Yes, sir.
Equal and opposite impulses are applied.
Yes, sir.
But they will not get converted into torque, because for point mass, it will only have translated motion.
Translated motion.
Because torque is what? R bar cross F bar.
Yes, sir.
R bar is 0 for a point mass.
Yes, sir.
Hello?
Yes, sir.
So therefore there is no question of torque. So if the point masses collide,
Yes.
okay, then you just have to apply the principle of linear, I mean whatever you do for linear collision, you have to do and do. There is nothing you can do about its angular momentum and angular collision as far as the point mass is concerned. But if it is a body, yes, it is involved.
Sir, earlier you have said for point mass collide with the rigid body. So
Ah,
for
yes.
point mass it will not fix it, but for rigid body there will be torque.
There will be torque. There will be torque for the rigid body. It is your only point. Or you consider both of them as point masses, then this will not be applicable.
Yes, yes.
Right? Very important.
Sir, do you mean like when an unconstrained body is not a free body,
Huh.
it can have the center of mass can have a translated motion?
Why?
Sir, like you had said,
What did I say?
if
Uncontrolled, it will have only what?
the center of mass will have a translated motion, so it will not have a rotational motion.
Why?
Like the body will rotate only about the center of mass.
Huh.
So only this impulse is zero about the center of mass. So when you say
No, what are you talking, man? See, if the 2 point masses collide, okay, then at the point of collision, there is exchange of force. This will apply force on this, that will apply force on this.
Yes.
These forces, see, force applied by this on that, force applied by this on this, are the two forces, but they will not get converted into torque.
Yes, sir.
And therefore, there is no question of, angular momentum change or all those things.
Okay.
That's the meaning.
Okay.